The Oxford Dictionary describes a black hole as an area in space that nothing, not even light, can escape from, because gravity, the force that pulls objects in space toward each other, is so strong there.
Once in, never out.
M87 was not a picture of a black hole, rather a picture with evidence, due to the fact the gravity of a black hole decreases as the distance of the source moves further away, much like any wave. However, gravity does not dissipate over space, but rather gets weaker and weaker with distance. Black holes are not vacuums. In fact, if we were to replace our sun with an equally sized black hole, the planets would still be in orbit and Earth would just breeze over. Let me just get this out of the way. Black holes do not lead anyone to a different dimension or alternate universe. Though theorized by Hawking, there simply isn't enough evidence to support it.
All suns have a delicate balance of radiation and gravity, where the radiation pushes against the gravity. In stars much larger than ours, the heat and pressure at the core allow them to fuse elements until they reach iron. Unlike all the previous elements, the iron doesn't produce any energy, and eventually the iron builds up, and the delicate balance of radiation and gravity is broken. And within a millisecond, the star implodes, moving at about a quarter the speed of light. This is when all the heavy elements in the universe are created, as the star dies in a supernova explosion. This will either produce a neutron star, or if the star is large enough, the entire mass of the star collapses into a black hole.
However, what we see is not the black hole, but the event horizon, the point of no return, in which anything may fall into, but only exceeding the speed of light may it exit, which according to Einstein is impossible. Theoretically, if a human approached a small black hole, they would be killed before entering the event horizon. However, with a larger black hole, they could enter the event horizon and survive several moments before spaghettification. On the outside of the event horizon, the swirling of space and light can be observed. This is due to the ergosphere contained by the static limit, named by Ruffini and Archibald in 1971 and created by frame dragging. Anything that passes into the ergosphere is forced to move in the same rotation as the black hole. Accretion disks are massive amounts of assorted matter and gas that collect into thin, hot structures around a black hole. Bright knots form and dissipate as magnetic fields move throughout the disk. The closer the disk is to the black hole, the faster it moves, and it can reach speeds close to the speed of light. The differences in speeds throughout the disk cause the bright knots to stretch, causing light and dark sections to appear throughout the disk. If the black hole is looked at from the side, its accretion disk would appear to go above and below it. In reality, the disk is flat, but due to the different speeds and movements, the disk appears to be misshaped. Plasma jets are ionized matter expelled from the poles of a black hole. Simulations show that as a black hole spins, its poles become coiled and spring outward into space, flinging the particles close to the speed of light and creating one of the fastest transportations of particles known to the universe.
The event horizon is scorching hot due to the light entering the black hole. However, the singularity is dark and dense, almost clocking in at 0 degrees Kelvin. Considering the black hole is 1 million times larger than the sun, it would take a few heartbeats to reach the singularity. The universe outside the black hole would seem to be moving faster the further you fell in. Before, you could travel infinitely but forward through time. In a black hole, however, you can only move towards singularity as physics and time cease to exist. You'll observe bright light particles surrounding your atmosphere. An elongation soon starts to occur due to the gravitational tidal forces of the black hole. This is called spaghettification. New light particles surrounding you will wrap tightly around you. You will shrink into a tiny ball as you reach the singularity.
The black hole in Interstellar was all based on real science. In fact, they hired the world's foremost gravity scientist, Kip Thorne, to write the mathematical equations that visualized the hole. You see, he had always imagined what it would look like, but even he was amazed by the outcome. And even went on to say that even the truth could be stranger than fiction.
In 1974, Stephen Hawking theorized the phenomenon of a black hole's death. This happens when particles, which are usually brought together, are now separated by the gravity of the black hole. One particle falls in past the event horizon and the other escapes into normal space. The forsaken particle, now without a partner, is seen as radiation emitted by the black hole. The loss of this particle also causes a loss of energy as well as mass to the black hole. As this continuously occurs, the black hole will get smaller and smaller until it suddenly vanishes with a massive explosion. However, this process takes billions upon trillions of years, depending on the size of the black hole. And this theory was named Hawking radiation and is widely accepted and studied by the astronomy community.
Oh yeah, and one more thing.
Never gonna give you up, never gonna let you down.